Hello, this is how we do or conduct the experiment simulation for Joule's equivalent of heat. Okay. This is experiment number 4, and the link for the simulation should be provided by your teacher. This is the link, okay? thephysicsAviary.com. Let us first look at how to use the simulation. So just click begin, and in the simulation you can set two values. Number one, set the voltage from your power supply by clicking this circle. And number two, set the amount of water or the mass of water. Now, because the density of water is 1 gram per cubic centimeter, that means whatever is the volume here is the same as the mass of the water. Let us go to our data sheet, and from there we will input the value. Let's use the value of 310 ml. From the data sheet, let me scroll forward to the data sheet. This one here. Okay. So we are going to write the value, the mass of the water, 310 grams. Now, because the mass of the water is already given automatically, you don't need to fill mass of the empty cup and mass of cup and water. However, just to explain how to get this too, to get the mass of water M, you simply need to get the mass of cup and water. So that's M plus a small letter m minus the mass of an empty cup. That's how we get the mass of the water in the lab. Let us go back to our simulation and let us start it. So once we start the simulation, we have to take note of three things. Number one, what is the initial temperature? Okay, which is the value here. And what are the voltage and current? Now the voltage and the current will be mostly constant. The temperature of the water is the only one which will change. Okay, so let's go to our simulation. What you do is read the initial temperature of the water. So of course it's fluctuating because it keeps on absorbing and losing heat from the environment. So let's use the number 5 degrees Celsius as the initial temperature of the water. Okay, so let's write it here, 5 degrees Celsius. Now let us start our simulation. Click the power, that's 67 volts, and 1, 2, 3, about 3.75 amperes, 6.7 volts. Okay, 6 point, is it 6.7 or 67? Let's check it out again. 67 volts. Okay, so 67 volts and approximately 3.75 amperes. Now what you will do next is you should prepare beforehand a note to measure the change in temperature, or simply the temperature reading. Okay, let's put this as T. The temperature reading versus the time. You will record the time in 30-second, the temperature, sorry, in 30-second interval. Okay, until, well, how many will your teacher ask you? In this case, let's just do 5 readings. Okay, but you can go as much as 10 readings. Okay, so let's just make a small window here. Now you have to take note that whenever the simulation is in the background, it's not opened, what's going to happen is it will pause. So you have to keep the simulation in the foreground. Okay, 31 seconds, it's 11 degrees. So let's record that one in our Excel file. So 30 seconds, that's 11 degrees. Okay, we can also add the initial time 0 and the original temperature 5 degrees. From here, you can get delta T. Okay, how do you get delta T? By equation, you will take this number minus the initial number. That's your delta t. Okay, 60 seconds is about 16 degrees. So 16 degrees. You have to focus on taking the time, the temperature at the right time. So the next should be at 90 seconds. Watch this time, okay, and enter the temperature. 21.7. So 21.7. 120 seconds. Now, ideally, you want to take as much data as possible to eliminate some errors during the simulation because of the fluctuating temperature. Okay, 27.4. So far, the increase in temperature is consistent. Now, simulations tend to have more than the normal result in terms of perfect data. Okay, we're almost there. And that should be 32.9. 32.9. There you go. You can now switch off once you've reached enough number of data. As I said, it is much better if you have a more set of data, like maybe from 0. 1 second, let's adjust this. Okay, maybe from 0 excuse me, up to maybe 300 seconds or even more. Okay, now it's time to graph your data. So select the points of t and a small letter t for time, big letter T for temperature. This will be your x-axis, this will be your y-axis. But you select only the data and then go to insert, scatter, and then choose this one with the line. Okay, and that's your graph. Easy peasy. You can increase the size of the graph. Okay, and then you can select the line, right click on it, and add trend line. Once you have the trend line, this is how it will look like. Okay, select here below display equation on chart. Once you have the equation on chart, let's increase the size. Okay, let's make it 24. So what does this equation give you? It gives you the general equation for the slope. So let's take a screenshot. Oh, this is projectile motion. Take a screenshot of your data like this. Your teacher will ask it from you. Okay. Now, how do you know which one is the slope? The general equation for the slope is y is equal to mx plus b, where m is the slope. So in this case, the number that comes with the x, that's the x-intercept, okay, that's the slope of the line. Okay, you will take this slope and you will use it to complete your calculation for Joule's equivalent or Joule's constant J. So 0.1851, go to your data sheet and then write the slope, okay, 0.18, what was that again? 0.18, oh, Microsoft Excel, 51, 1851. Now you will substitute the values here to find J determined. That's how you will collect the data from the simulation, and good luck in doing your experiment.